Huh. Hello. Today's lecture is based over the signal and its classification. Uh, Here, signal is defined as a function of one or more variable which convey information. Now, whenever we say a signal, then always it is generated from any one of the sensors, transducers. Generally, the signal generated from these sensors and transducers are always a function of one or more variables. It may carries current, voltage, frequency, phase, space. All these information will be carried with the help of that signal. To define the signal, a signal is a physical quantity that varies with respect to time in general or any other independent variable. It can be dependent on one or more independent variable. Now when we say if it is dependent on one or more independent variable, then we will define these signal in three categories: one dimensional signal, two dimensional signal, and multidimensional signal. So as example of one dimensional signal is x1 of t is equal to 20t, or x2 of t is equal to 20t square. Generally, the example of one dimensional signal may be a voltage, current, phase, frequency, or any ECG signal are coming under the one dimensional signal. Now when we talk about the two dimensional signal, then two dimensional signal carries two independent variables. Okay, as per the definition of two dimensional signal, when we say two dimensional signal, if the signal contain two independent variable, then we will say it is a two dimensional signal. Now in earlier signal, one dimensional signal, only t was present, but in terms of two dimensional signal, we can see here a signal is represented by g of x comma y. X and y are the two variable, these are the two independent variable, and the signal is represented by g of xy is equal to x plus 3xy plus 2y square. So here this expression results a two-dimensional signal. Now when we talk about the multidimensional signal, the multidimensional signal are nothing but a signal carries multiple independent variable. Example, x of t is equal to summation of I is equal to 1 to n. Okay, so when I is equal to 1 to n, a I of t sine in bracket 2 pi fi t into t plus theta I into t. Okay, so here the multiple variables are ai of t is equal to time varying ith amplitude. It is an amplitude signal. Fi of t is time varying ith frequency, and theta I of t is equal to time varying ith phase. Now when you talk about the multidimensional signal, then multidimensional signal carries air or wind pressure is the best example of multidimensional signal. Okay, air or wind pressure, okay, it is a function of four independent variable like latitude, longitude, elevations, and time. These are the four independent variables. Because of these four independent variables, we can say this is a multi-dimensional signal. Now we look examples of these signals. Here, the one-dimensional signal is represented by a ECG signal or a speech signal. Here, they are shown in top side. Similarly, two-dimensional signal is nothing but a picture. A picture is example of two-dimensional signal. Here, in this picture, the signal is varying in X and Y direction. And in terms of multidimensional signal, here it is represented by I in bracket X comma Y comma T. Okay, so here X and Y are the variable and T is the third variable. So these three variables are independently varying. Okay, so they are represented as R, G, B signal, red, green and blue light. Because of this light intensity, here these signal are represented. So I in bracket X comma Y comma T is represented as IR of XYT, IG of XYT and IB of XYT. Okay. Now to go over the next point here. Now, these are the examples. These examples are related to electrical signal. In terms of electrical and electronic circuitry, you may find voltage and current will be flows through circuit. So here these signals are considered as electric signal. Acoustic signal, generally audio or speech signal are called as acoustic signal. They are analog or digital. Similarly, video signal. In terms of video signal, intensity variation in an image. Okay. Example, a CAT scan. Okay. Similarly, biological signal. Biological signal is a sequence of bases in a genetics. Okay. Generally, ECG, EEG, EMG are different biological signals that we can able to find. Also, noise is an unwanted signal. Okay, so these are the examples of signals. Now we go for classification of signals. Now whenever we talk about the classification, then the signal classification is based on parameters used to classify them. Okay, so here near about different parameters are shown. Example A, nature of independent variables such as time. So time is one of the independent variable. So here continuous time and discrete time are the example of nature of independent variable. Then nature of dependent variable. Okay, here analog signal and digital signals are coming under dependent variable. Similarly, number of independent variable like one-dimensional, two-dimensional and multi-dimensional signals are coming under this criteria. Then based on periodicity of signal, generally periodic and aperiodic signals are coming under this category. Then it is based on nature of indeterminacy. Okay. So indeterminacy means whether the signal is deterministic or non-deterministic. So that's why we say it is a deterministic signal or random signal. Then based on causality, signal may be causal, non-causal or anti-causal. And last one parameter is it is based on energy content in the digital signal. Okay, so energy content in the signal are energy signal, power signal, neither energy nor power signal. Okay, so these signals are coming under this category. Now, to go through these classification, we consider these categories. Okay, with this category, we explain the classification of all signals. Okay, in first category, signal, single channel and multiple channel signal. Second is single dimensional and multidimensional. Third is continuous time and discrete time. Fourth is continuous value and discrete value. Fifth, analog and digital. Sixth, deterministics and random. Seven, periodic and non-periodic. Eight, symmetrical and asymmetrical. And energy and power, and last is causal, non-causal and anti-causal signals. Okay, now we go through it one by one. We understand the definition and their examples one by one. Okay, now single channel and multi-channel signals. If a signal is generated from single sensor or source, it is called single channel signal. Okay. Now, whenever a signal is generated with the help of a sensors, okay, there are many kind of sensors that you have seen. Okay, that may be a source. Okay, so that's why we say it is a single channel signal. Now, most of the cases we may adopt multiple sensors for earthquake determination or temperature measurement point of view. When we have to measure a temperature of a city, then we will pair multiple temperature sensors in a city and we take the average of that temperature. So in the same fashion, if the signal are generated from multiple sensors or multiple sources, or multiple signal are generated from same source, called multi-channel signal. Example, ECG signal. In terms of ECG, multiple sensors are putted over our body and the ECG is taken. Then second example is here EMG or EEG. All these signals are coming under the multi-channel signal. Okay. Similarly here, the multi-channel signal will be the vector sum of signal generated from multiple sources. Okay. Now, second point, single dimensional and multi-dimensional signal. As we already talked about the single dimensional, two-dimensional and multi-dimensional signal. Okay, so as we have discussed, if signal is a function of one independent variable, then we say it is a one-dimensional signal, like speech signal. Okay, if signal is function of m independent variable, we say it is a multi-dimensional signal. So example is grayscale level of image or intensity of at particular pixel on black and white TV is example of multi-dimensional signal. Now, third point is continuous time signal and discrete time signal. So we go through definition and what will be its graph. Okay, see in this slide here you can see a graph is shown. Okay, a sinusoidal signal is shown on the coordinate system. So with respect to t, the amplitude is varying. Okay, the amplitude is represented by x of t. Okay, it is a continuous time signal. So that's why x of t is represented mathematically as a into sine omega t. A continuous signal or a continuous time signal is a varying quantity whose domain, which is often time, is a continuum. Example, a connected interval of the reals. That is, the function's domain is an uncountable set. The function itself need not be continuous. Okay, so in terms of continuous signal, the signal are varying with respect to time. Okay, we will say it is a continuous time signal. Okay, now second point is discrete time signal. Now, discrete time signal are defined only at a discrete interval of time. Okay, for these signals, the independent variable takes on only a discrete set of values. Okay, so in the graph here you can observe the discrete time signal is shown. Here on x-axis it is represented by n, and on y-axis it is represented by x of t, but it is represented by x of n. By mistake it is written as x of t. Okay, now at bottom side its expression is given x of n is equal to a cos omega n. Okay, whenever we talk about the discrete time signal, you can define it as it is a signal defined only at discrete interval of time. Okay, now the next one is we will compare the continuous time signal and discrete time signal. The signal, now in terms of continuous time signal, you can say like this: the signal can be defined at any time instant, and they can take all values in the continuous interval in bracket a comma b, where a can be minus infinity and b can be infinity. Okay, means a signal is continuously varying with respect to time, and it is varying at a continuous interval from minus infinity to infinity. Now, in terms of discrete time signal, it is represented like the signal can be defined only at certain specific value of time. This time instance need not be equidistant, but in practice they are usually takes at equally space interval. So by the definition, you can understand what is the difference between the continuous time and discrete time signal. Now, again, few points are there that we are comparing both. Now, in terms of continuous time signal, these are described by differential equation, and the discrete time signal are described by difference equation. Okay. Similarly, in terms of continuous time signal, it is denoted by x of t, and the discrete time signal are denoted by x of n or x of n into t. Now, the continuous time signal, the speed control of a DC motor using tacho generator, feedback, or sine or exponential waveform are example of continuous time signal. Microprocessor and computer-based system uses discrete time signal. Okay, so this is about the comparison between the continuous time and discrete time signal. Hope you got this. Now, continuous valued signal. Now here Continuous valued signal are very similar to your continuous time signal. Only differ is that here, if the variation in the amplitude of signal is continuous, then it is called continuous valued signal. It is represented as x of t is equal to a cos omega t. By nature, it is a cosine waveform. Okay. Next one, discrete valued signal. Now here, discrete signal are defined at discrete interval of time, but here it is a discrete valued signal. So as per the definition, we see if the variation in the amplitude of signal is not continuous, but the signal has certain discrete amplitude, then it is called it is called continuous, it is called discrete valued signal. Okay, so discrete valued signal are shown in this waveform. Okay, between 0 to 1 its amplitude is 5. Okay, but between 1 to 2 time its amplitude is 10. Similarly, between time period 2 to 3 its amplitude is 15. Again, between 3 to 4 time period, its amplitude is 20. And lastly, 4 onwards, you can find its amplitude, that is x of t, is 25. Okay, so you can say it is a discrete valued signal. Okay, these are the various discrete level that discrete level are considered as discrete value of signal. Now, here continuous value and discrete value signal are compared. Okay. Now, in terms of continuous value signal, if a signal takes on all possible values on a finite and infinite range, it is said to be continuous valued signal. In terms of discrete value, if signal takes value from a finite set of possible value, it is said to be discrete valued signal. Now, continuous value, in terms of continuous value and continuous time signal are basically analog signals. And discrete value, the discrete time signal with set of discrete amplitude are called digital signal. Now here, a comparison between analog signal and digital signal is given. Okay, so we are familiar with the analog as well as digital signal. Okay, so here we see how you can compare it. The analog signal, these are basically continuous time and continuous amplitude signal. In terms of digital signal, here these are basically discrete time signal and discrete amplitude signal. These signals are basically obtained by sampling and quantization process. Analog signal, ECG signal, speech signal, television signal, etc. All the signal generated from various sources in nature are analog. Digital signal, all signal represented in computer and digital signal processors are digital. This is about the comparison between the analog and digital signal. Now, periodic signal. A signal which repeats itself after a fixed amount of time interval is called as periodic signal. Here, a wave is shown. In this wave, a x-axis is represented by t and y-axis is represented by x of t, and a sinusoidal wave is shown here. If you look the sinusoidal wave, then this signal is repeating. Okay, so as per definition here, if a signal repeat itself after a fixed amount of time interval, it is a periodic signal. Okay, so here x of t is equal to x of t plus t0. Okay, a period of repetition, that is t, is repeat after some interval of time. Now examples are given. Examples are cos in bracket 0.01 pi n. Okay, so here this signal is a periodic signal. Similarly, cos in bracket 3 pi n, again this signal is a periodic signal. Okay, if you put the value of n is equal to 2, you can verify it whether the signal is repeating itself or not. Now, a non-periodic signal. Now, a non-periodic signal, if the signal does not satisfy above property, is called non-periodic signal. Means if a signal is not repeat itself after a fixed amount of time interval, then we say such natured signal is a periodic signal. So we look what is the aperiodic signal, how you can show. So a non-periodic signal is shown in this waveform. On x-axis it is represented by t, and on y-axis is represented by x of t, and mathematically it is represented as x of t is not equal to x of t plus t0. Here the nature of the signal is decreasing signal. It is a decreasing exponent signal. So this decreasing exponent signal has initial amplitude level is nearly equal to 1 and reaches to 0. So here this signal is not repeating after some interval of time. So that's why we say it is a non-periodic signal. Now next, now here comparison is given between the periodic and aperiodic signal. Now as per the definition, we already did the comparison in terms of periodic signal which repeat itself after a specific interval of time is called periodic signal. And in terms of a periodic signal, a signal which does not repeat itself after a specific interval of time is called a periodic signal. Now, again, some points are given for comparison. See, a periodic signal, in terms of periodic signal, a signal that repeats its pattern over a period is called periodic signal. In terms of a periodic signal, a signal that does not repeat its pattern over a period is called a periodic signal or non-periodic signal. Third point, they can be represented by a mathematical equation. A periodic signal are not represented by any mathematical equation. In terms of periodic signal, their value can be determined at any point at time. And in terms of a periodic signal, their value cannot be determined with certainty at any given point of time. Now, Periodic signal or deterministic signal. A periodic signal or random signal. Example of periodic signal is sine, cosine, square and sawtooth waveform. Example of aperiodic signals are sound signal from radio or all types of noise signal. By figure, it is also represented in comparison. Okay. Now next, now here we go for even and odd signal. Now here a even signal is represented in a wave. See, on x-axis you can find the time and on y-axis you can find x of t. A square wave is represented between -1 to +1. So here signal time is represented as x of -t and x of t. Okay, when you have to define even signal, you can define it in this way. A signal is said to be even if it is symmetric about vertical axis at at origin. Means at x of t, if you hold this signal, then you can see its mirror image is present. Okay, so that's why you can write its mathematical expression as x of t is equal to x of minus t, or in terms of discrete time signal, the t is replaced by n, so we can write x of minus n is equal to x of n. Now, odd signal. The odd signal is represented in a diagram. Okay, here a square wave is represented in negative side as well as in positive side. See here, you can define the signal is said to be odd if it is not symmetric about vertical axis. That's why you can say such types or such natured signal is a odd signal. Mathematically, you can write it as x of minus t is equal to minus x of t, or in terms of discrete time, you can write x of minus n is equal to minus x of n. Now, power signal. A signal is said to be power signal if it is normalized, average power is non-zero and finite. Here, a wave is shown. In this wave, you can find on x-axis n is written, and on y-axis u of n is written. Here, every interval is marked with 1 amplitude. Means the value of n will be varying from 0 to infinity. So each interval has u of n is equal to 1. So here the power p is equal to half. Okay, so the definition of power is written as P is equal to 1 upon T integral of minus T integral of T0 by 2 to T0 by 2 minus T0 by 2 to T0 by 2 x mod of x square of T dt. Okay, so this is a definition of power signal, or by simply you can say a signal is said to be power signal if its normalized power is non-zero and finite. Now, energy signal. The energy signal is shown in diagram. Okay, here a exponent signal is shown. In this from this exponent signal, energy of a signal is calculated. Okay, definition of energy signal is a signal is said to be energy signal if its normalized energy is non-zero and finite. By expression, you can write E is equal to summation of n is equal to minus infinity to infinity mod of x square of n. Now, the power and energy signal are compared. Now, power signal are infinite duration. Energy signal are finite duration. Power signal normalized power is finite and non-zero. Energy signal are normalized energy is finite and non-zero. Power signal are normalized energy average over infinite time is finite. Energy signal normalized power average over infinite time is zero. Power signal are mathematically traceable. Energy signal are physically realizable. So this is about the comparison between the power and energy signal. Now we see deterministics and random signal. Now deterministic signal are deterministics in nature, means we can able to determine with the help of a mathematical expression. See, behavior of this signal is predictable with respect to time, means whatever the signal that which we observe in the wave, its behavior we can easily predict with respect to time. There is no uncertainty with respect to its value at any time. This signal can be expressed mathematically. Example, x of t is equal to sine in bracket 3t. So that's why we say it is a deterministic signal. Okay, now random signal. When we talk about the random signal, then random signal are random in nature. The amplitude of the random signal will be not traceable. So that's why the signal are called random signal. Now we see by definition, the behavior of this signal is random, that is not predictable with respect to time. So that's why we say here the random signal are not predictable. There is an uncertainty with respect to its value at any time. This signal cannot be expressed mathematically. For example, thermal noise generated is non-deterministic signal. Okay. Similarly, the lightning discharge. Okay. So these are non-deterministic signal. Now we see the comparison. The deterministic signal can be represented or described by a mathematical expression or lookup table. Random signal that cannot be represented or described by any mathematical equation or any lookup table. Deterministic signal are preferable because for analysis and processing of signal, we can use mathematical model of the signal. Random signals are not preferable because the random signals can be described with the help of their statistical property. So that's why they are not preferable. Deterministic signal. The value of the deterministic signal can be evaluated at time. Example, past value, present value or future value that you can extract from any time without certainty. Similarly, in terms of random signal, the value of random signal cannot be evaluated at any instant of time. Example of deterministic signals are sine, cosine, exponent are the waveform. Random signals. Generally, the noise or space signal are considered as random signal. Next, now the last point is causal, non-causal and anti-causal signals. Now in this wave, in this slide, you can see the wave shown like this, x of t and okay. Now here the causal signal is represented in first wave where I giving you a mouse cursor. See, this is a wave. Okay, now when we talk signal is causal, now the definition is a signal is 0 for t less than 0 and signal is present when t is greater than 0. Then that signal is called causal signal. Okay, now if you look this wave, in this wave x of t is varying with respect to t but only in positive axis. In negative axis, that is minus t, it is not varying. Similarly, a non-causal signal is said to be non-causal when its value is present for t is less than 0. When its value is when it generally the non-causal signal are not present when t is greater than 0. So in the second wave here you can find x of t is present only in negative axis. In positive axis x of t is 0. Okay. Now here in terms of causal signal we say a system is causal if output of system at any time depends only past and present input. In causal system, the output is function of x of n, x of n minus 1, x of n minus 2 and so on. Examples are given a real-time DSP system. Similarly, in terms of non-causal, a system is non-causal if its output is dependent on future input. Example, x of n plus 1, x of n plus 2 and so on. Generally, it is considered for offline system. Now, here you can see right and left-handed signal. A right-handed signal is 0 for t is less than t and left-handed signal is 0 for t is greater than t, where t can be positive or negative. Okay, so that's why here this is about the classification of signal. Now for this time I am stopping here. Okay, this is about the classification of signal. Okay.